From AMC 2025 12A. The harmonic mean of a collection of numbers is the reciprocal of the arithmetic mean of the reciprocals of the numbers in the collection, and they give you the example there. The real question begins here with what is the harmonic mean of all the real roots of the 4050th degree polynomial and this scary looking equation. And so first we want to look at the roots of this scary looking equation. And so the roots of this is just the roots of this, and then the roots of this, and then the roots of this, and then so on and so forth, and then we include the roots of this. So the roots of this big 4050th degree polynomial, each of these 2025 smaller quadratics, each contribute 2 roots. And so the harmonic mean of these is just going to be 1 over 4050, and let's call these roots. Let's say R1, R2 is going to be in here, then R3, R4, that's going to be from here, R5, R6, that's going to be from here, so on and so forth until we get to R4049 and R4050, which are going to be from here. And so we want to find the harmonic mean of these. So we get 1 over R1 plus 1 over R2 plus so on and so forth until we get to 1 over R4049, 1 over R4050. We're getting a little crowded here. And so this is the harmonic mean here. And we want to find this. And what we can do here really quickly is just because we have each of these quadratics, let's try grouping these in terms of 2. So let's just, without the loss of generality, let's take this first one, 1 over R1 plus 1 over R2. And it's pretty standard that we can figure this out is equal to R2 if we just find the common denominator and, do the addition. And what's really key about this form is that we can actually find out this form by Vieta's formulas. And Vieta's formulas, basically for quadratics, say ax squared plus bx plus c equals 0, we can find the roots, we can find these two expressions for the roots, and say the roots are r1 and r2 of this quadratic. And so what we can basically find is that Vieta's formula says r1 plus r2 is going to equal minus b over a. And then r1 times r2 is going to equal c over a. And so these are really, really important formulas because we can just use the formulas to get the numerator and the denominator here. And so the numerator, r1 plus r2, that's just minus b over a. And so if we look at our polynomial here, or quadratic here, minus b over a is just 4. So we get 4 in the numerator. And then in the denominator, you get c over a, which is just minus 3. So we get minus 3. And so that's R1 plus R2. And let's try looking at R2 plus R3 because we're going to have to do this for, we have to do this 20-25 times. And so R2 plus R3, or R3 plus R4, excuse me, we're going to have this equation because, we can do the same process here to get this. And so let's just find this out. And I'm going to write down the polynomial so we don't have to keep scrolling. It's 2x squared minus 4x minus 3. There we go. And so by Vieta's formulas, R3 plus R4 is going to equal minus b over a, which is 4 halves here. And the denominator, R3 times R4, is going to equal c over a, which is minus 3 halves, which again simplifies to minus 4 thirds. And so this leads us to a nice pattern. Every 2 of these roots always going to sum to 4 thirds. But is it? So let's try proving it. And, in the real competition, you can probably just assume this pattern is going to hold because, well, there's not really a good reason why it's going to break. And, they're under a time constraint, etc., etc. So in the real competition, I just assumed this holds and I went with it. But let's actually try to figure out why this holds. And the reason happens to do with the actual structure of the polynomial. And basically the way these polynomials look is we have like kx squared minus 4x minus 3. And so if we do Vieta's formulas here, the sum of any 2 of these roots is always going to be 4 over k because it's going to be minus b over a. The product of them is always going to be minus 3 over k because that's c over a. And so 4 over k over minus 3 over k is always going to give minus 4 thirds. And so for all k, that's going to, in the range 1 to 2025, we're going to have that it's always going to be minus 4 thirds. So every pair of 2 is going to equal 4 thirds. And how many pairs do we have? We have 25 pairs of this 4/3 here. So basically this just simplifies. HM equals 1 over 40 50 times, we have 25 copies of -4/3, because each of these roots, or each of the pairs of 2, simplifies to the same thing. And so now we just simplify this, and we can cancel this out. This leaves a 2, get this out. This also leaves a 2, and so we're left with 1 over 2/3, and there's that minus there, I'm just taking it out, which equals -3/2. And so that's going to be our answer.